And hello everybody, welcome to this video series. Welcome to this video series. It's called Labview Frequency Analysis and a little bit of fun. Okay, so what is this series about? Okay, it's I'm basically just getting started with Labview, and I intend to, as I learn, I post videos. Yeah, I'm basically learning how to use Labview, but as I learn, I post videos and uh, hopefully to help you get introduced around Labview in a quick and hopefully fun manner. Now, what is Labview? Labview is it's basically one of the software that allows you to interface with data collection systems or data collection probes, for example, temperature probes, etc. And it's by National Instruments. So that's the very layman way of saying things. Of course, you can do way more than what I just said, but that's basically what you need to, control machinery. Right? A lot of people, when they do stuff in the lab, they used to control temperature or control whatever. They use a Labview, and even to make controllers, PID controllers, if you know what that is. Okay, but anyhow, I assume you know what Labview is and roughly why you want to use Labview, but I'm basically going to start working with frequency analysis because I'm interested in periodic phenomena. Okay, so I assume you are as well, but so first order of business, of course, is the installation process, which I won't go too much into detail here. I'm only saying that Labview does support Linux, but it only supports Red Hat, OpenSUSE, and Scientific Linux. Well, for me, I use Linux Mint 20, or the Uliana version, which is based on Ubuntu 20, Focal. And it's not a Windows, obviously not a Windows distribution. I always like Linux, prefer Linux over Windows. So yeah, I tried just doing a bare bones Labview install. Apparently it still works, thankfully. Okay, so it does work on Linux Mint 20. I just look for the install script and I go sudo sh and then you get install. So you look for your Linux ISO in the ISO directory and run sudo sh install, and this will install Labview into user local National Instruments. Now I tried the same for Linux Mint Debian Edition, LMDE for Debi. I've not been able to get it installed as of yesterday, 21st September. Okay, I'm not going to try for the sake of time, but it works on Linux Mint 20 and I'm happy with that. There are some websites, some people have done the tweaking necessary to make Labview work on Debian based systems, not counting Ubuntu of course, but that's all in the link here. Alright, I've sort of started making a GitHub of Labview, so you can go and check it out. Some of the VIs are there just to get you interested into some of the interesting functions that are there. Okay, so right. So this is basically Labview, how to install it, and basically, assuming you have installed it, we'll want to work with get ourselves familiar with Labview. All right, I assume you have no Labview or minimal Labview experience like me, but interested in working with frequency domain stuff. Okay, we're basically getting let's say a time domain data. Okay, I'm not going to waste time here. Okay, I'll just get straight into the meat. I assume you know what frequency analysis is, so I'll skip that part. Okay, all right. So Labview has a lot of things you can do with frequency domain analysis. A lot of tools there, so it can be a bit intimidating for first timers. I know I was intimidated, okay, but after watching some tutorials and having a little bit of fun along the way, I came up with this little bit of a tutorial just to get you started on the basics of what Labview is about, and some of the frequency domain analysis things. So what is all this here? What is all this simple diagram that you see here? Well, I'm going to get you started by making a new VI, alright, a new file, Labview file, which is called VI. Right, and why are we interested in in that? You'll see shortly. I mean, why are we interested in why do I have wave files here, for example? You will see shortly, right? So let's go. We start. I'm going to close all of this and don't save. Okay, I'm going to start a blank VI. So don't create a project or anything. Just make a blank VI. Okay, VI stands for virtual instrument. Okay, so that's basically where you start your Labview. Now I'm going to, of course, pull these two parts into the left and right. One of these is called the block diagram. The other thing is called the front panel. So the block diagram is where you will do all of your usual nitty-gritty programming and stuff, where you see all these wires and little boxes going everywhere. Most of your behind-the-scenes work is over here. Whereas at the front panel, why do we have a front panel here? Just imagine yourself sitting at a control room, and then you have a bunch of controls with which to manipulate stuff. Then you will be interfacing with a front panel with like maybe joysticks. All right. Yeah, you will be sitting on a panel with maybe some joysticks over there. You'll be seeing maybe a lot of displays. Now, where you give Labview your inputs and outputs, most of it you can do it here in the front panel. Okay, so you'll be switching back and forth between the block diagram and front panel a lot. So these are the two main views you need to get used to. I'm going to close the block diagram first, and I want to save it as a new VI. Let's call this the YouTube demo VI, because I'm demonstrating a new Labview on YouTube. So I'm going to close this. Okay, I'm going to close this, and when I open the YouTube Labview VI, all right. Okay, sometimes Labview doesn't open right all the time. You'll only be shown the front panel. Okay, so this is a blank file. There's nothing in there, but normally when you open a new VI, you will only be shown the front panel. So how do you actually navigate to the block panel? Just press Ctrl E, and you will see the block diagram. It works on Linux and it works on Windows. This is what I've known. If you want to see, of course, I don't know. Yeah, if you want to go and see the block diagram, it should be under File. You see this top panel here. Go to Window, and then you see this thing called Show Block Diagram. And then likewise, if you're at the block diagram, you can go to the Window part, and you'll see Show Front Panel. So if either of these are closed, or rather, okay, if your front panel is open and your block diagram is closed, just press Ctrl E, or you can go to this Windows part. Okay, so I'm just going to go show you through some basic navigation back and forth, because that's very important. Okay, so you don't get too confused. All right, now first order of business, we want to when we're dealing with frequency domain stuff, we want to analyze perhaps certain periodic motion. All right, so where is a convenient place to start? Okay, a convenient place to start would be perhaps to analyze a sound file. Okay, so normally Labview, you can take in data from a microphone, or you can take in data from the thermocouple or whatever sensor you have. I assume that we all poor, I guess, poor students, that we don't have the money to afford all this. So I'll be basically working with bare bones what we probably have. You probably have, if you're watching this, you probably have a phone, or you're running Labview. If you're running Labview for that matter, at least you will have a laptop with some microphone and camera. Okay. All right. So what what you are able to do to start your journey with a little bit of this frequency domain suite, or get used to the tools here, are basically to get sound files, alright? To make sound files. Alright, so in Windows it is much easier to work with the sound VIs. However, for Linux it was a lot harder because it requires this thing called Open Sound System. I've included a lot of the notes here under the README MD. Okay, the README file in my GitHub. Alright, so there are some YouTube resources here for you. It uses the Open Sound System that's required for getting data from the microphone so that it can be ported into Labview. Unfortunately, that itself requires the installation of this thing called Open Sound System. Now for Windows itself, it does not have this problem, but for Linux, it does have this issue. It needs Open Sound System, and I tried messing around with that, and it gave me a little bit of headache, so I quit working with my microphone. So the other alternative, which shouldn't take too much trouble, is that you use something like Audacity. Okay, Audacity is you can find it inside your app store if you're using Linux Mint. Okay, Audacity. You can download it online as well. This is a very famous, well-known video editor. Oh no, sound editor. So you are able to record your sound here, and then you export it as a WAV file. Now once you have a WAV file, alright, once you have a WAV file, you should be able to import it into Labview as well, and then hopefully you get a sound or waveform from it. Okay, and eventually you want to have sort of a graph, right? You want to have a sort of a graph of amplitude versus time, so that you will see, in your sound file, if there are parts that are louder, you will see a bigger amplitude. There are parts that are softer, you will see a smaller amplitude. And all these are to deal with periodic motion. So, okay, let's begin with the end in mind. What do we want at the end of the day? We want a graph. So go to your front panel, okay, because you want to have a graph display on the front panel after all. Okay, so you right click over here, right click on the front panel, not in the block diagram. Go to the front panel and right click, and you go to this part called graph, hover over it. Alright, I'm going to repeat again. Right click on the front panel and you say, yes, we want a graph, right? And then you see all of these tools here. You will probably get a little bit overwhelmed by the number of tools that are there, but forget everything and go straight for this part that says graph. Now there are two things you can try. One is called a waveform chart and one is called a waveform graph. Now if you have real-time data, okay, what's the difference between both? You can of course use both, it will be fine. But the waveform chart is more like if you have instantaneous real-time data being fed in. But okay, I'm going to use the graph. Okay, I'm not going to elaborate too much on that. Both are actually fine at this point in time. You don't really need to think too much about it. But okay, I'm just going to go with a graph. Okay, so what is this graph? I want this graph to be called the audio. Okay, and it's going to show again the amplitude versus time. And okay, what can you do with it? Okay, if you want to rename the title, you go to this part, double click, and you should be able to say, okay, this is my audio graph. All right, so you should be able to even change the scaling by doing this here. If you want it to go from 0 to 50 seconds, for example, you can always change this part, 160 if I want to change this. And again, the amplitude here I can just easily change to maybe 80 or something like that. So this is roughly how graphs are, and of course you can shift it around inside this panel. Alright, you can shift it up and down, and of course you can use your mouse wheel to scroll up and down within the front panel. Now for this block diagram, you can also use the scroll wheel to scroll up and down, but sometimes if you accidentally click like this, alright, you can't use the arrow keys to move around. What you need to do is actually to go to the scroll bars at the bottom and scroll left and right. Go to the scroll bar at the bottom and scroll left and right, and that will be able to bring you back to where you kind of started. Okay, so if you accidentally go to the right a lot, go to the scroll bar at the bottom and shift it back, and you should be able to go back to where you started. Okay, so there are a few ways of navigating in Labview, and this is what you do. Use the mouse wheel, or you can use your scroll bars, but sometimes they will turn off because, well, this is where your little graph function is, and if you scroll to the right using this mouse, you can scroll bar back to the original part. But by default, Labview does not allow you to scroll to the right because there's nothing, or towards the right is just white space. So the only way to scroll there is to use the mouse button. Okay, if you want to go back, remember always use this scroll bar at the bottom. If you want to scroll to the right, use the mouse, and then you just drag, left click and drag. Okay, so do get used to this. Can be a little bit frustrating if you are doing a first time thing, but okay. So this is basically what your output is like. All right. So what are your inputs that are required? Okay, you basically need an array of x and y values. Okay, so I actually, you can actually manually key in your own arrays, but I kind of find that a bit boring. I want to have a bit of fun, right? So I want to work with real audio files here. Okay, so let me give you an example of one audio file I kind of recorded. Okay, so this is one audio file I recorded over here.
Never gonna give you up, never gonna let you down, never gonna run around, never desert you, never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you.
Never gonna give you up, never gonna let you down, and that was what I was singing. So I basically just rickrolled you in the name of education. Alright, so basically I have this audio file here, which is me singing Rick Astley's Never Gonna Give You Up and rickrolling you. But I want to put this file into Labview and see the resulting waveform. How can I do it? Okay, so don't worry, I won't play that again just to annoy you. But first thing first, what you want to do is to input. If you want to convert your wave file into an array, go to the graphics and sound, and go to sound. Okay, and from input you see this part saying read. Okay, and I know that's a bit confusing. Let me do it again. Right click on the block diagram, not the front panel. Go to the block diagram and right click. Okay, under functions you will see this first part called programming, which is open by default. You'll see all these other files at the bottom, all these other functions, just ignore them. Go to this folder called graphics and sound, and you hover over it. Go to the part that says sound. Okay, hover over it, and then this new window will open. Go to the part saying input, hover over it, and then you will see this window. Alright, and you will see this sound input read.vi, which is this read thing here. So click that and place it here. Alright, so what can you do with that? Okay, I'm going to save this. I'm going to save this first. Okay, so I'm going to save it. Okay, so what can you do with the sound VI? Okay, so you can go to the part saying show context help window if you're not sure. So click on this VI, and then go to this question mark under the block diagram. It says show context help. Okay, so once you put context help, you can do this. Now let me demonstrate again. Go to the question mark, click the question mark. Okay, it will say show context help. If you hover over your specific VIs, you will be able to. Okay, let me try one more time. show context help, click this, hover over the VI, or the so-called express VI, or little blocks that you want to find help for, and then it will show the help over here. So if I will go to the context help here, and I hover over the sound read VI, it will show you this. Okay, so this is what basically what you need to note. Okay, so what it will do, it will take in some samples, and then it will output a data in the form of the array. So what it's not input data in form of the array, but yeah, it's going to give you some data in, I think, amplitude and time. Then you'll need to construct an array from it. Okay, so that's basically what this VI is doing. It's going to take a sound file and convert it into some data, which can then be constructed into an array, with which you can then plot a graph. So this is just some basic reading of a sound file. Alright, continue more in the next video, but thanks for watching.